We're looking at cubics today. So in terms of cubics, we looked at factorizing cubics in the last video. We're looking at graphing cubics. Very, very similar to graphing cubics in terms of quadratics, where we find the x-intercepts, the y-intercepts, graph it. However, the main difference between a cubic and a quadratic is the look of the graphs a little bit different according to what they actually intend. So when we're looking at cubics, let's quickly look over that formula itself again. So it's formula being x cubed plus bx squared plus c plus d is equal to 0. And we get those two different points. When a is greater than 0, we know that our graph is going to be increasing. So think about, if you get stuck with these kind of things, think about the linear gradient. The gradient, it's increasing, it's going to be rising from left to right up. If it's decreasing, it's going from left to right down. Okay. Another thing that you need to be in tune with is that, like quadratics, you're going to have more than one x-intercept. You could have more than one x-intercept. When it comes to cubics, the highest amount of intercepts you're going to get are going to be equal to the degree. So we could get 2. The highest we can get is 3 types of x-intercepts. We're going to go through those types of graphs in this video, and in the next video we're going to go through some examples. So let's talk about the different types of graphs. If we look at the different types of graphs here, the first one is nice and simple. Okay. Again, it's just an x cubed. So in this case here, we're going to have something that kind of looks like that. Okay. It's positive, x cubed goes through the origin. Nice, straightforward one. When it comes to the second example, you can notice in this example here we have 3 types of roots, alpha, beta, gamma. Okay? And in this instance here, I'm going to get rid of this y-axis because I don't want to have to deal with any y-intercept. All I'm talking about here is I'm going to be having 1, 2, 3. So here would be alpha, here will be beta, and here will be gamma. Okay? So we've got our 3 different roots according to what it looks like. Our third example relates back to something that you learned when it came to quadratics. If we've got something that to a power of 2, then we're bouncing off the equation at that point. So in this case here, if we've got something to the power of 2 in this case, we could have, up and bouncing off. So in this case here, in this one I could move these around in terms of what I've got for my functions. So I would say that this here will be beta and this here will be alpha. So it's crossing the x-axis at beta and touching at alpha. Okay. This second last one here is a little bit strange. And it's strange in the fact that it does something similar to the squared, except for it doesn't just bounce off, it lays on that little line part and then moves on. So, I don't know why I keep doing the y-intercepts for. So if we look at this one here, this here would be where alpha sits. So I'm going to come up, go along the axis a little bit, and then come back down. So really want that to be a nice smooth line. So the question people ask me is, well, how far along do you go along that x-axis? If this here is alpha and you've got theta here and let's just say gamma here, you're only going along the point where it is important. We don't go any further along to just confuse this, so we just go across where alpha is in this case. So up, along the x-axis, continually moving up. The last one here is if we have a quadratic where the delta is less than 0, we're only going to be having one x-intercept. because these things here are going to give me no real roots. So if it doesn't have any real roots, then it's still going to be a positive graph. It's just that it's going to be cutting through this point and continuing up. So cutting at alpha. So remembering that if we've got, and this is still going to be a cubic, because if I multiply these against each other, I'm still going to get that ax cubed. Okay? However, because this here is less than 0, and we know that in stage 1 methods, anything less than 0 has no real roots. So therefore, if it has no real roots, then it must have what we call complex or imaginary roots, and they don't exist on this x-axis. So therefore, we only cut the x-axis at where the real root occurs. These here are the 1, 2, 3, 4, 5 different types of cubic equations or cubic graphs that you're going to come across in this course. Really important to remember how they work, what they look like, especially when it comes to sketching a graph. And also when you've got one of these graphs, you know what the equation should look like. Next video we're going to do some examples on some of these. I'll see you then.